Hello everyone. On behalf of State Council of Science, Technology and Environment, I would like to welcome all the viewers and especially my students to this online classes. So today is my second class. So I will continue my lecture on the same chapter which I did in the last class, and the name of that chapter is Surface Area and Volume. Today I'm going to discuss the surface area and the volumes of a cone and a sphere. So let us start first with a cone. So a cone is something like this, which has a circular base. This is the radius denoted by R, and this is the slant height of the cone, which is denoted by L. And this line perpendicular to the radius is the height of the cone. This is a perpendicular line. It is the height of the cone. Now, first I'm going to find the relation between the slant height, the height, and the radius. Let me consider only this part. I got something like this. So this is the radius R, this is the slant height, and this is the height. So this is a perpendicular line. So the angle here is 90 degrees. So this is a right angle triangle. So I'm going to find the relation between L, H, and R using Pythagoras theorem. So by Pythagoras theorem, we have this is the hypotenuse, this is perpendicular, and this is the base. And Pythagoras theorem states that the square of hypotenuse is equal to the sum of the square of the other two sides. The other two sides are h and r. So here you get h square plus r square. So taking square root both sides, you get L equal square root over h square plus r square. This is the relation between slant height, and radius. So now I'm going to find the surface area, the curved surface area of the cone. Let me recall some formula which is from the chapter of circle. This is a circle of radius R. This is also of radius R. And this part is called the minor sector of a circle, and this part is called the major sector of a circle. And this arc AB is called the minor arc of a circle, and this other arc is called the major arc of a circle. Let me write the formula of the minor arc. Length of minor arc AB. Minor arc is this part. So it is given by theta by 360 into twice pi radius. But radius here is r. Twice pi r. That is the length of a minor arc AB. And also we have the area of a sector. Let me write the formula. Area of minor sector. It is given by theta by 360 into pi r square. This is the area of a minor sector. So these two formulas I'm going to use in finding the curved surface area of a cone. So a cone is something like this, which has a slant height L and a radius R. So, which also has a height H. And to find the curved surface area of this cone, I'm going to take out first the circular base. I'm going to consider only the curving part, right? So, I take out the circle, I left only the curving part. So, I will cut this cone. After cutting, I cut something like this, which is a part of a circle, and this is called the sector of a circle. Let me draw it in the board. After cutting this cone, I cut something like this, right? And this region is a part of a circle. Let me complete the circle. So, a circle always has a radius. So, this is the center, and this is the radius. And what is this radius, right? So, what is this radius equal to? This part, if I deform again this cone, this radius will equal to the slant height of the cone. So this will be the radius of this sector will be the slant height of the cone. And what is this part? Let me write here, note here, O, and this A, and this B. And what is the length of this arc AB, right? So if I deform again this cone, see, I got a sector. If I deform again this cone, we get a circular, right? A circular base. So this part is equal to this circular part here. And this circular part here is called the circumference of the circle of radius R. And this is equal to twice pi R. Right? This is of radius R, not L. Right? So this part is equal to twice pi R. So length of arc minor arc AB minor arc AB is theta. This is angle theta. Theta by 360 into twice pi radius. And what is the radius of this circle? The radius of this circle is L. So twice pi L. Length of a minor arc AB is given twice pi R. Twice pi R equal to this quantity, theta by 360 into twice pi L. As you can see, twice pi and twice pi are common, so get cancelled. We left with R is equal to theta by 360 into L. So I will denote this as equation 1. So this is a minor sector, and this area is equal to the curved surface area of this cone. So here, let me write in short, the curved surface area of cone is equal to the area of this minor sector. Area of minor sector OAB. So the formula is given by theta by 360 into pi radius square, but radius here is equal to L. So pi radius square, right, pi L square. So 3 by 360 into pi. This is L square. I will split and write as L into L, which is the same thing. L into L is equal to L square. So I will group this together. I will get pi L into theta by 360 into L. And this quantity is equal to 1. As you can see from this equation 1, R is equal to theta by 360 into L. So this quantity, I will replace it by R from equation 1. So curved surface area of cone is equal to pi L into R. So I will arrange the term. I'll write as pi R L. This is the curved surface area of a cone. Next, I'm going to discuss about the volume of the cone. So a volume can also be obtained from the volume of a cylinder. Let me take a cone and a cylinder. This is a cylinder. Here I have a cone of height h. Also, I will take this cylinder of the same height as this cone, height h. And this also, the cone has a radius r. So I will take a cylinder of same radius as that of the cone, right? So to find the volume, I will do some activity in which I will have something that volume of cone is equal to volume of cylinder. But the question is that will one cone equal to one cylinder? That is the question. But here I'm going to show an activity how many cone will equal to one cylinder. So I will perform an activity. So here I have a cylinder of height h and a radius r. Also, I will take this cone of same height as that of the cylinder and also the same radius as that of the cylinder, right? So, and also with me I have a powder here. In the last class, I've discussed with you that whenever we talk about volume, we have to make the space of this object to be occupied. So I have with me here powder to fill the space of these two objects, right? So we will count how many cones will fit here in the cylinder, right? So let me first take the powder, full cone of powder, full cone of powder. So I'll fill here in a cylinder. As you can see, there is still space inside the cylinder. So I will add some more powder, a full cone of powder. Again, I will fill here in the cylinder. the space is not being occupied. So I will add some more. Until now we have filled only 2 cones of powder. Now this is the 3 cones. So I fill here. As you can see that this cylinder, the space of this cylinder has been occupied, fully occupied. So until now, how many cones has been occupied in this cylinder, right? Until now, we have 3 cones of powder to fill the space of this cylinder. So from this activity, we observe that 3 times the volume of a cone is equal to volume of one cylinder. So now 3 times the volume of a cone is equal, and volume of cylinder is known to us, and that is pi r square h, right? Then this is 3, and here we have a sign multiply. We take this 3 to the other side, and left here with volume of cone is equal to pi r square h divided by 3. So equal to 1 by 3 pi r square h. So this is the volume of the cone. So I am done with finding the surface area of a cone and also the volume of a cone. Now I left out with the surface area of a sphere and the volume of a sphere. So a sphere. A sphere, something like this. It's like a ball. And apart from that, we also have a hemisphere. Which is half of the sphere. And also a sphere has a radius, and let me denote it by r. Same here, radius r, right? So first I'm going to discuss the curved surface area of a sphere. Here I have with me a ball, right? And Archimedes, he was a Greek mathematician. He proved that the curved surface area of a sphere can be obtained with the help of a cylinder. So he took a cylinder of same radius as that of the sphere. Same radius as that of the sphere, and the height of this cylinder is equal to the diameter of this sphere. So h is equal to twice r, right? So Archimedes, he proved that he put this ball inside this cylinder like this. He put the ball inside this cylinder, and he observed that the curved surface area of a sphere is equal to the curved surface area of cylinder, right? But curved surface area of a cylinder is known to us. It is given by twice pi r h, right? But h is given to us that is equal to twice r. So I will replace h by twice r, and here 2 into 2 is equal to 4, and we have pi, and r into r we have r squared. So this is the curved surface area of a sphere, and here we have a hemisphere, which is half of the sphere. So the curved surface area of hemisphere will equal to half of the curved surface area of a sphere. So half, as you can see from here, the curved surface area of a sphere is 4 pi r squared. So I will substitute here as 4 pi r squared. So 2 into 2 equal to 4. So we'll get 2 pi r squared. This is the curved surface area of a hemisphere. Now, I'm going to discuss the volume of a sphere and a hemisphere. But first, let me discuss the volume of a hemisphere because it is easy to perform an activity, right? Like we did in a cone. I have with me a hemisphere and a cone because the volume of the hemisphere can be obtained by the volume of the cone, right? So I have with me a hemisphere of radius r. This is of radius r, and this cone is of same radius as that of the hemisphere, and the height of this cone is equal to the radius of this hemisphere. So let me count how many cone will fit in this hemisphere, right? So with the help of this powder, I will transfer this powder in this hemisphere. So let me take a full cone of powder. A full cone of a powder, and transfer here in hemisphere. This is one. This is one, and you can see that the space is still there. So I will add some more powder. And this is 2. This is 2. And you can see that the space has been occupied. From this activity, we see that 2 volume of the cones is equal to 1 volume of the hemisphere. So now, from the activity we get that volume of hemisphere is equal twice the volume of a cone. Twice, but we know the volume of a cone, it is 1 by 3 pi r h, pi r square h, right? Pi r square h. But h here is equal to radius of the hemisphere. So 2 into 1 by 3 into pi r square into r. I replace h by r. So we get 2 by 3 pi r square into r, we get r cubed. This is the volume of a hemisphere. So now we are going to find the volume of a sphere. Volume of a sphere. And you know that 2 hemispheres will equal to 1 sphere. 2 hemispheres will equal to 1 sphere. So volume of sphere is equal to 2 times the volume of hemisphere. And this is 2 into, and volume of hemisphere is 2 by 3 pi r cube, and 2 into 2 is equal to 4, which is equal to 4 by 3 pi r cube. So now we get the volume of the sphere and as well as the volume of a hemisphere. So until this, I will stop up to here. So in the next class, I'm going to discuss some problems regarding with the help of these formulas of these 5 objects. So thank you so much.